Hello, today's lesson we're going to talk about simplifying radicals. So I've had some questions about this. So remember when we are talking about square rooting, we're talking about the opposite of squaring. So it's important to know some basic numbers that get squared. So here's our basic perfect squares over here. I wrote them down. So 2 squared is 4, 3 squared is 9, then we get 16, 25, 36, 49, 64, 81, 100, 121, and 144. So you should have those memorized. And if you want to make a list for yourself at the edge of your paper, that's also pretty helpful. So when we're trying to simplify radicals, if the number underneath our square root is not on the list, then what we want to do is we want to break it down so that it is a product of a number on the list and something else. So if I go through, I can figure out that 72 divided by 4, so I'm just going through and dividing it by the numbers on my perfect square list, is 18, so that works. So that one is a factor of 72. 72 divided by 9 is 8. So we know that's also going to be on there. 72 divided by 16 is 4.5. So that does not go into 72, so that one's not going to be on my list. And so on and so forth. So what I'm going to do is I'm actually going to do this problem two ways. The first way is if we didn't find the biggest perfect square factor of 72, and the second way is if we did. So let's take a look at the first way. So let's say I check out 4 and 9, and I say, okay, well 9's bigger than 4, so let's go with 9. So then I can rewrite this as 72 is the same thing as 9 times 8. And then I can rewrite that as the square root of 9 times the square root of 8. And the square root of 9 is 3, so 3 comes outside of the radical, and then the 8 stays inside the radical, so 3 root 8. But if I look, 8 still has a perfect square factor because 4 goes into 8. So then I can continue to simplify, and I can rewrite that square root of 8 as the square root of 4 times the square root of 2, because 4 times 2 is 8. And then the square root of 4 becomes a 2, so I get 3 times 2, and then that other 2 stays in the radical. So then my final answer here would be 6 square root of 2. Now there's a faster way where we don't have to simplify the radical anymore, and that's if we had seen that 36 actually goes into 72. So 72 is 36 times 2. And so if I had done that way, I would have the square root of 72 equals the square root of 36 times 2. And the square root of 36 is going to be 6. So then I wind up with 6 root 2. So that way is a little faster. So even if you don't get the largest perfect square right away, you can still figure it out. You just might have to double check what's left over in your radical. Okay, let's do one more example. This one, I included some variables. So this one we have the square root of 147 x squared y to the 5th. So what I'm going to do is I'm going to take the 147 and try and simplify that. So we're just going to look at the square root of 147. And we're going to look at our list, and we're going to try and find the largest perfect square factor. So I'll give you a minute. Go ahead, pause the video. Try and find the largest perfect square factor yourself. Okay, now that you're back, I hope you found that 49 was the largest perfect square factor of 147. So I can write 147 as 49 times 3. Okay, and then if I'm going to look at x squared is a perfect square factor. So the square root of x squared is x, which is nice. And then if I want to look at y to the 5th is the same thing as y to the 4th times y. And y to the 4th, if I take the square root of that, that's y squared. Okay, since y squared times y squared is y to the 4th. All right, so let's put this all together. So the easiest thing to do is to separate this radical into two radicals. Your first radical has all your perfect square pieces. So 49, x squared, and y to the fourth. Those are the perfect square pieces. Then the non-perfect square pieces are going to go in the second radical. So 3 and y. All right, so my first radical, I have 49, and then I have all of the x's, x squared, and then 4 of the y's, y to the fourth. Then in my second radical, I have all the leftover factors. So I have a 3, there's no x's because we put them all in the first radical, and 1 y. And now when I look at that first radical, I can take the square root of each of those factors. So square root of 49 is 7, square root of x squared is x, and square root of y to the fourth is y squared. And then I'm left with 3y. So that's how you would simplify those. And you have about, I think there's 10 or 11 homework problems where you're just practicing simplifying radicals. So email me if you have any questions while you're working.